mentioned that it is said that to catch each error and not just use a general flag, which is the exception flag, to catch all errors. Now, the reason is because if it conditions, your if and else conditions, yeah, how they work. Now, you will notice that you are actually directing a flow of program from one place to another. So if something happens, let's do this. Else, let's do the order. It is exact same concept for. I'm sorry, can you hear now? Yes. Can hear you. Okay, it's clear now. Okay, good. So the idea is that you catch every single error. Now that is because the exception flag is also doing a lot, catching every error. Whereas there are things you will need to do for specific types of error that you're trying to catch or handle, right? And the first approach that I always try to use is that run the program, let the error happen, and then catch the error, see the error, catch the error. Try to give my system permission to share my screen. I don't know why it doesn't have permission up to now. Okay. Just give me 2 minutes to reopen.
Okay, please just hang in there and we'll be back to join us. Please, if you have any questions at all, you write it down, and when it gives us the chance to speak or to ask our questions, then we ask our questions. Okay, so just a minute and he'll be back.
I am back on now. Can you hear me?
I can hear you, sir.
Okay, good. All right, so I can share my screen. Just let me know if you can see my screen. Can you see my screen?
No,
Can you see my screen?
Yes. Yes.
Okay. So let me wrap this in. I just open it. So just name it anything. Doesn't matter what I name it. So let's try to work on something together. Um, okay. Main.py. All right. So let's work on something together. Let's say, for example, we have the popular word guessing game, right? We have that word guessing game number guessing game, where you get a random number. Let's import random as R and let us ask the computer to guess a random integer equals ran R dot ran int between the range of 0 to 5, right? And user gets an input. Sorry, input. And yeah, enter guess. And then if comp equals user, let's just print that yes, this happened, which is correct. Else, print wrong. I don't think I have Python extension installed here. Okay. Okay. So we have this. Let's get rid of this. And let's run the program. So it is sorry. All right, enter a guess. I'm going to just say 5, and I'm wrong by default, right? Now let's also print the answer, which is print computer, to be sure that yes, everything is correct. Setting 5 again. Computer got 1, right? Before we enter, let's print the computer answer. And let's do this again. So computer gets 2. Let me enter 2. You see that I'm still wrong. Who can tell me why I'm wrong? Who can guess why I'm wrong here? Anybody? All right, blessing. All right.
I guess it's because it's a string.
Exactly.
Your input-
Because it's a string. And then what I'm getting from here is an integer, right? Now, that is an error that I need to catch, right? That's an error I need to catch, right? I'm comparing an integer with a string. It's an error I need to catch, meaning this guy has to enter an integer, right? So I'm coming here to say try, right, to convert this guy, right, to an integer, right? So I can just come here and say data equals user, right? Dot is I think int or is num, right? So try to do this, and if it works fine, right, then do all of this except, right, print input must be an integer, right? Now I'm entering 3, and then it says input must be an integer. All of this didn't work. And let's try again and enter 3 because it's the same answer. And then I got nothing, right? I got nothing because this worked, right? It's a number, fine. And then we checked, right? And it wasn't correct, right? So it didn't do anything, right? And then jumped to this and just said input must be an integer again, right? So you have to always be careful with your exceptions. Now, what we're actually trying to do here is to check whatever is typed here. Now, there is this concept in law that says um, the accused is not guilty until proven guilty, right? When it comes to programming, the user is guilty until not proven guilty. Now, let's not check for number again, right? Now, let's do something else. Let's comment this out, right? And let us try to do this. And I will run this program and I will enter K2 and enter TWO. Now, you expect your user to type TWO, right? But now we want to first convert this to an integer to make sure that yes, it's an integer. We are comparing an integer with an integer and run again. And now 0 and then 0. Let's say 0. Now must be an integer, right? Because this is actually wrong. But then if we brought this out here, let's copy this out and just try to comment this first. I just run it like this. We get something different, an exception, right? Okay, we have indentation error. Okay. Where is this except coming from? Okay. So we have base 1 and then ONE. And we have a value error, right? We are trying to compare an int literal with a string literal, right? And then the int function, which is the type converter here, could not convert this to a number data type. Now, this is one error we need to actually look out for, right? You need to look out for every error that is going to be faced and then catch all of them. Now, somebody has entered this. Now, what do we need to do here? Let's get rid of this again, and let's unwrap this. Now that we've converted this, we need to now check, right? And try to do all of this. If except it's a value error, and catch for value error, right? For value error, we want to say input must be a number in digits, right? E.g. 0, 1, 2, 3, 4, and 4 and 5, right? And this will actually solve our problem. And let's enter 5. And it said input must be a number within this, right? Letting the user know that yes, this is what you are expected to provide. Hence, now a good example where this works is when you visit websites and there are fields where they ask you for a phone number. You discover that your keyboard automatically picks numbers instead of general characters, right? But when they ask you for password, it picks more of password. And for sometimes, when a field is asking you for email, you see that the @ symbol, instead of being in the symbol section, it is outside where you can actually easily pick it, right? Now, all of this is decided using exceptions in different languages depending on which platform you are building your software for. In our case, we are building with Python. And then there is the finally. If you try to do this, right, and it doesn't work, right, what are you catching? You are catching this error, and then there are other errors you might also want to catch. For example, let's say we are building a calculator. Let's get rid of this first. Let's get rid of this as well. Let's be the calculator to calculate for area of a circle. That is it's pi r square, right? That's r square pi times r raised to the power of 2. I think that's the formula for area of a circle, right? Or am I getting it wrong?
You're correct, sir.
Yeah. So pi is what? 27 over. What is value for pi again? I know we have
20.
pi in the
22 over 7.
32 over 7.
Yeah.
So 22 over 7.
Which gives us a floating point number, and we need the radius, right? Which is an input from the user. Input from the user. Enter radius r. Wait, let's put this radius r, and yeah, don't mind my Mac keyboard. It keeps giving me extra characters that I didn't ask for. All right, so we have our radius, we have our pi, and
No, sir.
yeah, go ahead.
Sorry
Yes,
to
go ahead.
disrupt you. So many people have been
Yeah.
complaining about the font size on the chat box. I'm sure you can't see it, so I don't know
Yes,
if
yes,
there's any
yes.
way you can help us expand so that we get to see. Thank
I
you.
think it's better now.
Yes, it
It's
is.
better now.
I think it's a
better
lot
now.
better.
Okay,
Yes, it's
sorry
better
about
now.
that. I like the small fonts for my eyes, so I can see clear. So pi times r raised to the power of 2, all in brackets. So treat this and then times pi by 8. So we have this answer, right? Now, let's just run this program and see. So it's asking us to enter radius, right? But we didn't print answer. Sorry, let's cancel this. So we have print radius r area of circle with radius r equals answer. So we have this to print. Now you see we have another error here, right? Keyboard interrupt. We'll treat that. So I've entered the radius of 5, and we get type error, unsupported operand. This raised to the power, right? And a string. So we need to catch for this and treat this and tell the user that yes, we know you made a mistake, but we don't want our program to crash, and we'll have to reinstall the software on the same machine again. So let's fix this. We have all of this. Now this is the only thing we are doing here after collecting the data from the user. So let's try to do all of this. And if it fails, accept, what is that? Type error. Type error. Right? And what should we say here? Print we encountered a type error between string and number. And let's run, and we'll fix that problem. Enter 5 again. Now we encountered this error, right? Now how do we fix this error? We don't know that this error exists, right? And this error is not because of the user, it's because of our program. Now we need to fix this, right? So to fix this error, all we had to do is just to convert this to an integer, a float. Now that is because our pi will always give us a floating number. I want to compare with a floating number, right? So let's do that here. Not our answer per se. Not our answer, sorry. Our answer should already be in float. What we need to convert is the R. But don't mind me. To float here. And run our program again, 5, and then we get our answer, which is correct. And now that we have this, right, we think our program is working fine. No, it's not working fine. Here, somebody is typing the radius for 5, and then we get a value error, right? We also need to check for this too. So we are doing except again. Here, another except for value error, right? And when we get a value error, we should only just tell the user, hey, we don't do that here. Please only enter a valid numerical number. You can add a bit of thanks. And run the program again, and I type 5. And hey, we don't do that here, right? And all of that. So we've been able to catch that error. Our program runs successfully to the end, and nothing happens, right? Now we have something else at the bottom here called finally, like I mentioned. Now, finally is, regardless of whatever happens, there's something you must do, right? Now let us print for this. In this case, let us print end of program. Are you happy now? Just to be a bit fun. Yeah. So we say 5. Right. It says this, and then it says end of program. Are you happy now? Now we are no longer getting the type error because we've converted our type correctly. Right. Hence, I'm no longer getting the type error. We converted our type here. Now that we've done that, there's another error here, right? We run this program and then we hit enter, and by mistake, I didn't do something and I hit Control C, right? I get a keyboard interrupt error, right? This is an error I need to also check, right? Now I can also, before my program start running, right, print CTRL plus C to end program, right? Now we can change this to accept, right, keyboard interrupt. Okay, not keyboard interrupt. That's the error we're looking for. And let's run our program again and just Control C to get the keyboard interrupt. Okay, this is not an error. This is part of the control error. And there's a way to get this using your system library, which is your importing your SIS and finding the keyboard interrupt error from there. It is inside there. But then that is something you need to also check for. It's more like somebody pressing. I believe some of us have experienced some applications where you press a button to exit an application, and then it asks you to press the button again, your back button again, to close the application. Just that you are sure that yes, you want to close the application, not closing the application by mistake. right? So this is something you also need to think about. So let's leave it as finally, and we have that. So basically, exception handling is not more than this. You can have multiple exceptions chained and then have them also indented. Same thing we do as well. Another way to do this exception handling here is to try checking, for example, this type error. We can check if this is an integer or a string, right? Using the string methods to know if it's a number or not. When we now know if it's a number or not, then we can go ahead and run our program going forward, right? So there are those methods that want to check if it's a number, if it's a digit, if it's a floating point number, if it's a string, if it's a character, if it's an alphanumeric number, and all of that, to check what your data is, what your user is feeding you. Remember, they are all guilty until they are proven guilty, and you have to prove them guilty by catching all their errors before they make that mistake, so that they don't have to make those mistakes ever again. That is just the overview of exception handling. There is nothing more than this for exception handling. Sorry, not except finally, just finally. Right? So I believe we understand this now.
Yes, we do.
Okay. So we can move on to more topics. If you, does anyone have any questions regarding this? Let me check the chat. I think I can see the chat here. Any questions? Okay. Okay. So no questions. So we can move on, right? Let's just get to object oriented. Which is more like my most favorite topic. Okay, blessing your question.
Okay, yes. I while studying about the exceptions and all of that, I saw another part that's apart from the try, accept, and then finally there was this exit. Sorry, else after
Else.
yes, after accept, after all the
Yes.
exceptions, then there was
Yes.
else before finally. So I don't know if you can help us break that down.
Okay. Else is a global keyword to do something when every other thing fails. Right? Finally is the opposite of else. Finally will happen regardless whether anything happens or not. When everything is done, finally, now do this. You get? Now the same way you have else for if, and else, right? Which is after everything is done and every other thing fails, else will always work, right? For if. Am I correct? I believe I'm correct.
Yes, yes, yeah.
All right, so just stay with me. Just stay with me. So same thing for else. If you are using for loop also, right? Mostly for while loop, you can always use the else as well. So if the while loop condition runs, right, then the else will not run. But if it doesn't run, else do this, right? So that's just what it is. So the else is just saying you are going to try to do this, right? And if it fails, if you get this error, do this. If you don't get it, forget about it. If you get this error, do this. If you don't get it, forget about it. And if you got this error, if you didn't get this error and you didn't get this error, and you didn't get any other error, right? And this still fails or through an error, then do this at the last. Okay? Do you understand that?
Yes, I do. Thank you so
So
much.
that's just what the else does. So when every other thing fails, then let it else work. Same thing for your while loops as well, right? Use that for while loops as well. Else, do this. And I think for your functions as well, you can still do that when your functions fail as well. For when you are trying to build data structures with functions that has to work with things like linked trees and all of that, then you can have all of that, even your objects as well. So else is just a global construct that says whenever that thing fails, as long as there's a condition, when that condition fails, do this. That's just what else is for. And yes, Python also has switch cases that other programming has have now, but most people still don't use it because our if statements pretty much does it for us. So that is just that. Let me create a new file called OPPY, and let me try to fix this in IntelliSense so I can use this. Okay. Conda deactivate. Okay, so we have this now. Let me open up my terminal again. Okay, so I use Anaconda on my system, Conda deactivate. Now we can do this. I think this should be working now. Command P. Sorry, Control P. Okay. So I have interpreter. Sorry. Python interpreter. Where is what I'm typing? Command alert. I need Python interpreter. Select Python interpreter. Okay. I think I have an issue with my C# here. Regardless, let's come back here. So object-oriented programming. You are bringing everything you know as an object. Now, in fact, Python allows you to be procedural, which is write your programs and wrap them, your blocks of code in functions, and do your life and live your life as a procedural programmer or a functional programmer, or you use object-oriented. But in real time, Python is an object-oriented programming language to its core. And everything in Python is an object. That is why I can do of 4, and I'll get Python .4/op.py. Python is not here. Under activate. So Python on my system. Wow. Python OP. So I have that this number here is belongs to a class of integer. We have 4.0 that is now belonging to a class of float, right? And wrap 4.0 in quotes, we have it belonging to a class of string, right?
Yeah.
Let's wrap it within
Junior.
square bracket. It now belongs to a class of list, right? Which in fact tells you that everything, every data type, everything in Python is actually a class or object oriented or designed for object oriented programming. Now, object oriented programming is just a way to see everything as an object, right? Everything as an object. And every object has two major things. It has attributes or properties, and then it has actions.
No, how I get
Right? For example, let's say we have an object, dog, right? Dog. Now, this is an object that we have, object called dog. Now, what are the attributes of a dog? Anybody?
The back.
Just list any attributes you know a dog has.
Back. Dog backs.
Has legs.
Sorry?
It has legs.
It has what? I didn't hear you.
Legs. Four legs.
It has legs. Yeah. Or number of legs. Number of legs. It has number of legs. It has a tail. It has a name. It has an owner. It has age. It has color. It has breed. It has what again? It has gender.
Of course.
Or sex, right? Whatever it is, gender or sex. I still don't know the difference between these two. Anyways, gender or sex. What else can a dog have again? Now there are some dogs that have that are hairy. So these are attributes, right? All of these are attributes. Now, there is something about these attributes, right? They can always change and they are not fixed, right? And then we have the second thing here, which are actions, right? Actions. Now, what can a dog do? A dog can walk. A dog can eat, play. A dog can run. What else can a dog do? A dog can bite. A dog can what again? Can swim.
Wag tail.
They can wag their tail. Wag tail. They can what again? They can fetch items, or let's call it fetch ball, right? So these are things that a dog can do. You can see the difference between the actions and the attributes. The attributes are just values that can change, that can be of any data type, numbers, strings, lists, or whatever it is, right? And then actions are things that they can do. So let's put this into perspective, and let's create another one, another object. Let's say kettle, right? An object kettle. But what we want to create is an electric kettle. And this kettle, right? What are the attributes of this kettle, right? We want the kettle. Now, to boil water, let's say we want to boil water, right? We have to take the water inside the kettle, take the kettle to the gas cooker or stove or whatever, and then we light our match or whatever we are going to use to light it, our lighter or matchstick or whatever to light, and place the kettle on top of the fire and wait for it to be ready, right? But then we want to simplify everything into an electric kettle that can just do everything for us. Let's assume this kettle can be connected to our water tank and can fetch water, boil it, and then make it ready for us or put it in a cup, right? And light the stove and everything by itself. Now, those are things you can do, which is light, let's call it actions, right? Light fire, get water, right? Heat water, right? Stop heating at 100 degree. What again can the kettle do? Put water in cup, make tea, especially anything you wanted to do. Then the kettle can have other attributes, right? Attributes can be that it has a manufacturer name, the manufacturer name. It has a model name, a model number. It has a size. It has an electric capacity and packaging type, color, handle type, might be leather, it might be cloth, or whatever. Now, these are different types of attributes you can get. It can be as many as you want. Now, these are two different types of objects. Now, let's create the first object. We have the dog, right? Now, for object-oriented design, right, we have two things that you need to learn about. Two things you need to learn about. We have one, right? OP has number one, it has a blueprint. Let's call it blueprint. It has a blueprint as well as it has the object itself or instantiation, right? Two things. Now, this blueprint is called a class, and the instantiation is called an object, right? This blueprint is called a data structure. Now, this is when you're working with data structures, right? This got a data structure, and then this instantiation is called a data type, right? That is why list is a data type, but then the class where it was created, which is the blueprint that data type came from, is called the data structure, right? That's just two things about object-oriented programming. And then remember we have these two things, attributes and actions. Now, it also has let's make it 3 attributes and has methods, right? These are actions, and these are called properties. properties or attributes. Doesn't matter. They are used interchangeably, but their methods are actions are called methods, right? So let's create our first class blueprint. To create it, you have the class keyword and then dog, right? Colon, and that is that. And I can say pass, right? And then I can come here and say bingo equals dog, right? And let's print the type of bingo, right? Let's print that. Let's run this. Now you can see it belongs to a class called dog, right? Forget about this underscore main. This is just saying inside this file, that is where the class is, right? This is the main file. Not this main I'm naming this, just this file, right? Now this main file is another file. This OOP is another file. So this file is called the underscore main, right? Which is named. All right. So we have that as the class dog. Now this is what we know as. Sorry. This is what we know as object, and this right here is what we call the object design. Sorry, object design, or we can also call this the blueprint. Class blueprint, or the object blueprint. So this is the blueprint to design this dog, right? And this is where the dog came to life. So this is more like God creating man from sand and from apes and wherever we came from. And then here is where life was breathed into man, or in our case, dog, right? So we create a class and then we instantiate a class, which is set the class to be alive. Okay, so here there are some things that has to have or happen with the class, which is some variables that has to be created, right? First, we have underscore on this, def underscore init underscore open, and then we have self, right? And now we can set variable names here, right? What are the variables that belongs to this dog, which are attributes, right? Now we're not going to take a lot of them. I'm also going to say name, right? Name, and we have what again? Let's say color, and then breed. Those are the three things we need to instantiate. And here we want to now say self dot again name. Remember, we're not calling self alone. Self dot name equals name, and I will explain. Self dot color equals color, and then self dot breed equals breed. Now, have we ever created functions before now? And we understand this concept of functions, right? Have we created functions before now? Anybody?
Yes, we have.
All right. So you can just unmute and speak. I think we should be talking and just discussing instead of having me just talk and talk and talk.
Okay.
Right. So cut me off anywhere and let's move this together. So
Okay, Mr. Moses.
yes.
So I want to be as honest as possible.
Sorry?
I want to be as honest as possible now. Can you hear me?
I can hear you. I can hear you. You are close
Okay,
to
yeah.
a fan, I
So,
think, and it's difficult to hear you.
can you hear me now?
Okay, I think it's better, I think.
Okay, so what I'm saying is that I want to be as honest as possible. So, a lot of us are new to this programming,
Yeah.
and this is the reason why we ran away from C. We actually felt like, for me, let me talk from my own perspective. We felt like Python is a lot more easier, which it is. But now there are some things you are defining that I have before. But you are doing it as if you know it before. Me, I don't know it, and I don't depth in it. I don't know what it functions. I don't know what it does.
Okay.
A clearer explanation
Okay.
let us know what.
Okay. All right. So I understand it now. All right. Let me confirm again. Who else doesn't understand functions? Who else doesn't understand functions? You can just signify by just raising your hand, so I know that it's only him that doesn't understand functions, or we have more people that doesn't understand functions. I want to know if it's what going into, or I can just point, or just giving pointers, or really need to understand functions. So I believe we all understand functions, right? Except we just spoke up now, right? Nobody's speaking.
I think without any response, it means that we understand functions.
Okay. So we all understand. Most of us understand functions. Now, for who just asked, yes, I'll just give an overview of function, right? And while I'm going on, I'll just keep referring back to functions because just something to wrap functions. So we'll still keep going over them. So functions are just a piece of code that actually wraps your code, right? So we have procedural programming, we have functional programming, and then we have object-oriented programming, right? Now, procedural programming is what we've been doing, or what we did here, where everything will run from top to bottom, which is why we have to comment some things out because we don't want them to run, right? While function is just a way to wrap the code inside a particular block, and then only when we call the function, it will become effective. Okay? That is just what functions are at overview. We'll see functions shortly again, but then this is a different kind of function, right? Now, there are, in classes, we have 3 types of functions, right? We have the constructor, the getters, and the setters. Let me write that down here. Let me just jot that down here. So for OOP, right? For OOP, we have 3 types of functions, but they are not necessarily called functions, but then they are functions in their nature. So I'm just going to say we have OP functions, right? And let's get this back. Okay, so we have this, and Yeah, we have the constructor, then we have the getters, and the setters. Now you see that the constructor is actually singular, while getters are plural and setters are plural as well. Now we'll get to what that is. Now this one here, this is a function, right, that initializes immediately you call this gets initialized, right? Now when we run this program again with just this, we're going to get an error. And we'll see. Now you see we get an error, right? It is missing 3 required positional arguments: a name, a color, and a breed. We are missing that, right? Meaning this class dog is expecting us to actually, let me bring this closer a bit. That's not actually provide these 3 names, right? Which is this value, and this value. And what this function is doing is just save it to himself. And himself is not this, right? This is the blueprint, and himself is this. So for bingo, it's going to have the set of names provided here for this. And we'll get a different dog. It will get all of this that this bingo has, but then Tango will have a different name, or probably the same name, but entirely different. And when you are doing things to bingo, it will not affect Rango, right? So let's just add that. So we have 3 positional arguments. We have a name for bingo, and then we have a color, which is orange red, and then we also have a breed, right? And bull, right? So that is the breed. And if we run this again, nope. Okay. Sorry, back here. So let's run this again here. And we get nothing. We only get this printed again, right? The error no longer didn't come out again. The error didn't come out again. Let's run it again and see. So we got this no errors because this guy was created. Now we have, again, I said getters and setters. Now you don't want to let anybody get any value from just your function anyhow as they want, right? But we can also do that here. Let's want bingo.name, right? Bingo.name. And let's print this instead. We get that it's a class of string because the bingo's name is actually a string, right? And let's just print it out. Let's forget about types now. We know about types. So we get bingo, right? But we don't want to allow anybody just access our values just like that. That is why we have getters and setters. This is a way to actually protect, for security, protect your functions. Sorry, your classes. Your classes should not allow anybody to just access values globally like that within the class. So there are ways to actually wrap this. Let's say I put underscore here, right? And then do this, right? It has no attributes underscore under the name. And let's try to get it like this. It still gives me that, I think it's double underscore for privacy. Sure. Yes, double underscore. Okay, start with double underscore here. Right, so we know that we have underscore name here, and we are printing underscore name here, but then it's telling us that this attribute does not exist, right? because it's a private attribute that shouldn't be accessed. Now you need to let people access whatever they want, you feel they should access, or what they should not be able to access outside of your classes. Now that brings us to methods, right? Which are getters and setters. So we want to get def get name. What am I writing? Get name and self. That is the only thing it gets. And what it's supposed to do is when we call it, it's just going to get us the name, right? So let's just return to it. Self dot underscore name, right? That's what we are sending back to this guy. And now here we can just do bingo.get name, like so, and run our program again, and then we get bingo, which is the name of the dog. And we can do the same thing for our other values here. Right, now these are what we need here. Now I'm not going to do for color and breed, but it's basically the same thing. But then let's do for actions now, which are methods. Let's just comment here, methods, right? Now methods. For methods, let's not define. I've talked about getters, not setters. Let me just do setters first before moving on to now we can get a value, and then this is how they can set a value, set name, which is update the name, and this gets self, and then new name, and here want to self dot underscore name will now be equal to new name. Right? That way, if you come here and say bingo dot set name and give it a new name and say the name is now Bingo Pro, right? And then run our program. I'm going to see name error. New name is not name. New name is not defined. It should be good to go. The set name that's on line 27. New name is coming from here. So let's run this. Oh yeah, it's correct now. So what was wrong? Because I didn't change anything. Anyways, that's it. We get this, right? And it's correct now. It's working. That's how we set or change values. Do we have any questions if I move to methods, which are actions? Classes are not that difficult, especially with Python. Do you have any questions? Okay, nobody's raising hand. Okay, somebody's not seeing my screen. Can you see my screen now, Ibrahim? Ibrahim, can you see my screen now? Okay, I think I will just move on. Not answering.
Hello, sir. I have a question,
Yes.
sir. That new name, is it
All right.
referred to as a variable? Is it a variable?
This new name here.
Yes.
Okay, so let's talk a bit about functions. Now, this is a function. All of this is a function, right? And a function does a few things. Now, we are defining a function by giving it this name, and we are saying this function should belong to whichever object. Remember, this is where we get our object. Let me specify. This is the object, right? Now, this function, when it's called upon this object, please work with this object and then collect something, which is set name, collect something. And what we want to collect is a new name for our dog, right? That's what we want to collect. And now, because our dog already has a name, when they gave birth to the dog, it was given a name by default, right? Now, we want to change that name that was given to it by default to now become what was given to it here, which is Bingo Pro. But at birth, it was given Bingo. Do you understand? Do you understand?
Yes.
Okay, so that's what this function is doing. Now, we have another function here that is getting a name, right? And all it does is just return whatever is in the name that is here, right? Back. Return it back to whoever is calling you. And the person calling is this, and they want to print it, right? So just sends it back. That's why it's not collecting anything, because it's just doing its thing, not collecting anything, right? And it belongs to whoever was called. Now, if I do the same thing here again, let's say I do, someone should give me another name for another dog. And in Nigeria, it's only Bingo we have.
Tiger.
Tiger, right? Name of a dog. And let's call this dog, right? And the name at birth is Tiger, right?
Yes.
Tiger, right? And then the color of Tiger is what? Let's say brown. I think that's good. And the breed is what? Let's say pit bull. Right? That's the breed. So let's make this object 2, right? We discover that when we run this Bingo.get name and don't mind me, I like copy and paste, and then Tiger or get name, we get 2 different things. Now this is what we get. Let's watch what we get. We get Bingo Pro and Tiger. Now, why do you think we have Bingo Pro and Tiger? Pro and Tiger instead of Bingo and Tiger. Anybody?
I think it's because you changed the name already.
Yes, I changed the name using this setter function that I create. Which methods like append, pop, and the rest of them, right? So this is what we just created, right? Now we have a basic idea of this. Now let's do one thing, and then let's try to recreate one of these aspects, which is a list to work with. So let's say we want to define a function called back, right? Now, this belongs to this dog, right? Now, how should this dog back? Right? Now, should it be different depending on the dog? If a bulldog is backing and a pit bull is backing, how different is their back? Hmm? Now, we might want to collect that. Um, woof, woof, right? And here, let's just get tiger does bark, right? And I'll run it. We get woof woof. Now let's also try bingo dot bark. We get woof woof twice. One for tiger and the second one for bingo. Right? Because we are asking it to do the same thing. But if we want it to be different, then we can specify the type of bark. Right? I call it we can do bar underscore sound here. Let's add our F string here and then barking woof woof or whatever. Now down here, I will not have to provide the sound. Right? Let's say tiger is barking roof roof, right? And then bingo is barking woof woof, right? We cover that it does exactly what it is we asked it to do. But then what is different here is that it is saying woof woof and roof roof, but then both of them are saying we are backing because within the function the method declaration, right? The blueprint, it has backing and the sound of the back. Is this a bit clearer now? Is it a bit clearer?
I think it is.
Do you understand what I'm saying?
Yes, I do.
Okay. All right. If you need me to explain it again, just let me know. I can go back to it. So
I have a
regardless-
question.
Okay, go ahead. Shoot.
Okay. When creating these functions, I realized that self is always the first
First argument.
argument of yes. So I don't know. Is it something that is static? Is it always like that? And then is it considered an argument?
Yes, it's an argument. One, yes, it's an argument. Is it considered to always? Is it a must for it to be there? Yes, it's a must for it to be there, but it's not a must for it to be self. But the Python community has said, let's just go with self, right? For example, in JavaScript, you use this, right? THIS, this. In PHP, you use this, right? In C Sharp, you use either this or you use something else, object, right? In JavaScript, you can also use prototype as well to actually access the current object. Now, whatever you are setting your initializing here, right? Make sure everything follows that pattern. If this is a dog, right? We can call this dog, right? And then everything else here changes to dog, to that dog. That was the first variable here, right? You can see that it's not highlighting again. Right? It's not highlighting again. I just changed everything now already. Yeah, I think I changed everything. And if I run my program again, what? everything is still working fine. Do you understand? So, what are we saying? When you are, remember I said this is our constructor, right? To construct the attributes that belongs to this class, right? Construct them, and then you are going to set what we need to get things from you, and also what we need to set or update your values, right? And then other methods. Now, this is a class job, right? Self is just saying this current object itself, right? Itself. Treat this itself. So if I create a method here and don't pass that first argument here as the first argument, right? It's not going to treat this based on this function alone. So based on this object alone, you are able to use it in other objects as well outside of this class. Do you understand?
Yes, I do. Thank you so much.
Now, this way is able to get values based on the instantiation, which is at this point and at this point here. Or initialize or instantiate the object. Remember, this is called an object and this is called a class. Right? Difference. Now, these are two different things. Now, let's just comment this out, right? All of it out, and then let's do something else. Right? Python is going to quarrel with us what we are trying to do now. I want to create a list, but then let's name it my list. My list. Now, a list, right, has a few things to it, right? And the first thing it has is what? That's lists.
Hi, Mr. Moses.
What I'm going to do here is,
Hello,
yeah?
Moses. Sorry to disrupt you again.
Yes.
Someone was raising his hand for some time.
Okay, I didn't see. Who was that?
Study teacher.
Okay, please go ahead. Study teacher, please go ahead. I'm listening. I can't hear you if you are speaking, study teacher. I can see you on mute.
Okay,
Oh, I can't hear you.
I'm not mute.
Okay, good. I can hear you now.
Okay.
I can hear you now.
Okay, sorry, because I was trying to throw more light on that question that Blessing asked, but I think your last response, I think, answered it concerning the self.
Okay.
Adding self to this thing, actions and properties and methods within a class. If you don't put that self, I think I still stand to be corrected anyway, but if you don't put that self, it's like you're putting that particular method, that is the attributes and the actions, you're putting them in a global scope.
Yeah, it's more like a global scope.
And when you don't put that self, you might eventually run into conflict. For instance, when you have classes or objects that have almost the same attributes or methods within them.
Yes.
Thank you.
Correct. Thank you so much. All right. So the beautiful thing about objects is that, like I've mentioned it since, blueprint, right? Now, take for example, you're an architect. Right? I'll just call somebody else. I've not heard their voice, but let me just look, right? And just what is that? Let me see who is here. Okay, I think I like Akpan and Joseph. Akpan and Joseph, I want to ask you something. What does an architect do?
Hello, an architect draw a blueprint
Draws a blueprint for a building, right?
yes,
And
for a building.
if you're an architect and you have a of a building, right? Is there only one building you can get from that blueprint?
No, I can get more than one building from the blueprint.
And then there are some things about that building that will always remain the same, right?
Yes,
And then
yes, sir.
for other buildings, things that can be different can be the color of the painting or the location of the building, right? But then the structure still remains the same. Yes or yes?
Yes, very correct, sir.
That is the same idea about classes, right? You have a blueprint, you can create multiple objects out of that blueprint, which is that class, but then the actions that can happen in that building, for example, the building will have solar, will have hybrid or hydroelectricity, and then probably a generator. We also have a good water system, that spring water coming in from the rock right inside the house or whatever, right? It has all of that. Those are things that always come with the design or the blueprint of the house. It has a parking space, it has a swimming pool, it has this, and they all look the same thing. Just like houses and estates always look like, right? But the position on the land in the estate that they are not the same. The owners of the houses in the estate are not the same owners. The people living in the houses are not the same. The amount of people or number of people living in these buildings are not the same. But then there are some things that remain the same, which is the blueprint. But every other thing can change, which are their attributes. The actions of the house will most likely remain the same, except extra actions that they can do, right? So yes, now that is just the concept of classes. Now let's try to create a list class. We're not going to actually create a list data type, right? But then we'll just play around to see how it works. We want to define underscore init, which is more like the first thing you need to define, to self, and then what it collects is nothing, right? Or collects asterisks, tags, right? And then default is empty. Now, we are saying when we create this guy, create something, and then if they didn't give it anything, make it empty, right? Close, and then what we now need to do is self. Let's make it global. Self.add equals args, right? Arguments. Now we have this, and let's just new list equals my list, right? And set it like this, and let's print new list dot tags. Let's run this and see. Valid syntax equals empty. Okay, sorry. For multiple arguments, I'm not supposed to give it a default value, right? But then let's run again, and then we get an empty tuple by default. I will get an empty tuple by default. Now, let's try to pass things here. Let's say we'll get 1, 2, 3, 4, 5, and 13 as a string, right? And run again. We get all of these values out, right? Now let's assume we want to add to this, right? How do we add to this value here? Who knows how we can add to this value? Now we can simply just convert this to a list, which means we are not creating a list actually. That's why I said we are not creating a list actually, but then we are playing around the concept of doing that. So let's say def append okay, let's say def put, right, self, and then it takes one value is data, and then it takes second value, which is not fixed, position, right? Position can be equal to -1 by default, which is add to the end, right? Add to the end of the list, which is -1, and then if position, right, is what equals -1, right, then self dot adds dot self dot adds equals self dot adds dot append data. Now this append now belongs to the list data type, right? But then we're using it to add to our own. And then we'll update our variable and we have that. Else, right? We do the same thing. Else we do the same thing. And by doing the same thing, instead of just doing this, right? We want to now get the position, right? And then position. And add it as a second value. So append will not ask for position. It is insert that asks for position. Sorry. So we only need one variable here. We don't need all of these cases. Sorry about this. I just remembered. So this is our put, and now we can now do new list dot put put, right, and then let's bring this guy again. So the first time we are printing it, we get this, and now we get none. No. Dot put. Yeah, dot put. We updated this guy who is already a list. Sorry, this is the only thing that we needed. Yeah, this is the only thing that we needed. All right, so let's go back. Now we get this and we get good added to the list. So we are basically creating a whole list, right? Now to print the list. They can basically just do dev get all, right? Self. And we can now ask it to just just print self dot ads, right? Now, instead of using this print, this, I cannot do new list dot get all. I will get the same result as before. Get the same result because it is actually doing what we asked it to do here. Mapping all of this within where it's supposed to be. Now, regardless of what you are calling it, you can actually call it anywhere, but then you have the right way to send the data to where you want to send the data. Now, I believe you understand the basic concept of object-oriented programming now from all of this that we've done so far.
Yes, sir. Thank you so much. I don't know, this particular code, is it possible to just copy and paste it in the chat box so that some of us can still go back and look at it again?
Okay, so I believe you are all in the group.
Yes.
Okay, so what I would do is that I can send the code to Dave, or Dave can add me to the group, and then I will just send you all of the files so you can have access to them.
Okay, thank you so much.
Yes. So I will just do that. So, any other question before I Ibrahim, go on.
Sir, how can someone
Yeah?
be in the group? I'm not in the group. They just send me the link, so I join.
Okay, ask the person that sent you the link to add it to the group that everybody else is. I think that's Dave. And I
Right.
think he's not here.
Right, I will contact the person. Thank you.
All right, so I just asked him to add it to the group so that
I'll
tell him I
put
said I will send
that-
the
I'll put his contact on the chat box so that you can reach out.
Okay. I'm just put the contact of the admin on the chat so they can reach out to
Okay.
you. Okay, so fine now. Let's go on. Now, these are the basic concepts of object-oriented programming. Now, there are a few topics you need to learn, right? Which is very, very easy, which is inheritance, right? Then you also need to learn about abstract classes. Abstract classes. Now, when you learn about inheritance, you will see abstract classes. You go to look for abstract classes, you will learn about inheritance. Right? So I've just listed them out there. Then you also have polymorphism, right? It is very, very important. I'm trying to remember every other thing that you need.
Encapsulation.
Yeah, encapsulation. And then one very big topic you need to learn. This is not about classes, it's about programming in general. It is abstraction. Right? Abstraction. Now I will explain this a bit. Abstraction is just the process of writing a code once and for all. So that you don't have to know how it works, but then you know what it does. For example, you buy a car, right? You want to drive the car. There is the starter key, right? As well as there is the brake, there's the acceleration, and all of that. Now, for every single car that we made, they will inherit from that standard design that is already in place for brakes and all of this. Now, you that is driving the car, you know if you match the brake, the car stops. You mash acceleration, the car moves, right? You turn the key to start, the car comes on, right? How does the key work with a switch that goes to the battery, that turns on the engine, that goes to connect to the fuel, and all of that? You don't need to know. Those things have been abstracted from you, and you are told to just start, right? When you mash the brake, are you using a hydraulic brake, or what kind of brake system is your car using? And how does it actually stop the car? How does it stop the engine or stop the tires or whatever? How does it work with the road? You don't need to know, but you know that this does this and this does that, right? The same way, Python, you see the print function. The print function, by the name alone, you can guess that it prints something. Input, you guess that it collects an input, right? Sum function, you know that, or you can guess that it sums everything up, right? And all of that. So these are just things relating to abstraction that you need to focus on, because in programming, everything you are doing is just to make the life of the user the easiest as possible. And that is what will differentiate the sheep from the goat, right? That's what will differentiate the sheep from the goat. Now, the goats will just write their code and just keep writing and have 3,000 lines of code, right? The good sheep will go back and refactor, right? Abstract, put functions in places where it needs functions, turn class functions to classes where they need to be turned to classes, and all of that. For example, you are creating a calculator, right? And then a calculator that does basic calculator does addition, subtraction, and multiplication, and it starts getting advanced, right? That's that you need to actually have a function for addition, subtraction, multiplication, addition, etc. And it starts getting advanced. Again, your calculator cannot do quadratic equations, cannot do calculus, cannot do this, cannot do that. But you have more functions scattered about, right? Now, because there are some values that other parts of your calculations will need. For example, you want to do statistical analysis, right? Which is a bit of statistics and calculus meshed together, right? There are times where you need formulas from statistics and times where you need formulas from calculus or processes from calculus, right? Now, you having a class, an abstract class that other classes will not inherit from, to share those properties is the best way to go about that kind of thing, right? Having that kind of calculator, having a class that has something that probably shares and they can inherit and just get from them and have their own methods that are unique to them. A class for statistics, a class for calculus, a class for this, a class for that. And then when you want to do statistical analysis that has to have calculus in it, you might have a statistical analysis class that inherits both calculus class and then statistics class. And you can get those values from them as well. So that is one very, 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 very important topic you shouldn't overlook. I'm just going to send the notes, and I don't want to take too much time. I know it's already about 1 a.m. on the other side of the world, while here it's still 11 p.m. It's 11 p.m., and which is a lot of time. But then we can have other classes anytime to just explain more concepts better. I am Moses Ogene, and thank you for wanting to learn from my gibberish or my babbling.
Wow, thank you so much, Mr. Moses. This was amazing. It was an amazing session. Okay, so David had to step out because of network issues, and then asked me to step into his shoes and wrap up for today. So once again, thank you so much, Mr. Moses. We learned a lot. In fact, one of my key takeaway points is when you said the lady who did whatever she did for the ship to be for the spaceship to be able to land and all of that. I started thinking of the problems I want to fix. So, so for me, it was an amazing session, and every bit of it, I learned a lot, and I intend to practice and perfect all that I have learned. I believe that every other person who has been a part of this class has also gotten value for the time. It was a time well spent. And I just want to appeal to us. Let's try to keep up with the classes, right? Let's try to keep up with the classes. I think one of the reasons why some of this concept for some people might not be clear is because of some classes that you probably have missed, and then is now looking like, because I noticed that this particular class brings together all the other things that we have learned so far. So let's all try to keep up with the classes and stay in touch with the community. Okay. I don't know if there's any other person who would like to share what they have learned or want to share an opinion. I think amongst us, if there's anybody like that, this is the right time to do that. Anybody want to say something? Okay. Yes?
Oh, my name is Dixon.
Okay.
I really want to appreciate Mr. Ogene for the impartation. It's like this is educational and spiritual impartation. Because it wasn't just about it also like a touch pricked our hearts, our imaginations. See, bringing in that the Apollo case, I think 18 something, about the woman who could write a garbage collector. Those things actually motivate, and actually I was motivated with the class. It wasn't boring, and the concept, the ideas wonderful. So I want to say thank you to Mr. Moses. We appreciate it.
Thank you so much, Mr. Moses, once again. In fact, from my end, it was like he was anticipating the questions in my heart. Before I asked them, he just answers them. It was awesome for me. Yeah. So to conclude the session
thank you everybody for.
Okay. Go ahead. You were saying something, sir.
Yeah. Sorry. One last thing I wanted to say that you should always have in mind, which is something I'm trying to fight against. So it's good I say it now. I forgot to say it at the beginning. So that is seeing programming languages as a tool, right? Now, we are aware of this fight that is always online, and people saying, oh, this is my language, this is better than this one, this is better, and that is better, and having all of those quarrels. Python is far better, JavaScript is this, all of this is that and that, right? But that is not the case, actually, right? Because I always use analogy. Take, for example, you are a carpenter and you want to make a table, right? Between a nail, a gum, right? A glue is nail, or just having a mechanism to just glue a screw. Which would you prefer to use to actually join woods together? I believe you want to use nails to join woods together, right? And then, what if you want to make a glass table? Would you use nails?
No.
You most likely want to use glue, right?
Yeah.
Yes.
And that is because glue is the best option for making that table, right, than using a nail. And depending on the kind of nail you are using, you have to pick a different hammer. You'll be using a hammer too big for a nail very small, or a hammer very small for a nail very big and strong, or a nail very big for a wood very small, or a nail very small for a wood very big, right? Now, all of these are just different tools that you can use to build anything. Now, what I think you should focus on learning is actually the concept of programming itself, which is solving problems. And there are processes to solving these problems, right? There are algorithms to solving these problems. Now, I'm not talking about programming algorithms. They are just processes to solving a particular problem. Step by step, things you need to follow to solve a problem. There are inputs you need to get. There are outputs you need to produce. There are processes you need to process to produce the output, or get inputs you need to get, right? Now, all of this will remain the same in every language. For example, I can be a Python developer. As a Python developer, I can write Python to build mobile apps that run on Android and iOS using Kiwi, right? I can build web apps using the Django. There is one now that I can just build even my front end using just Python for websites. I can decide to use just Python to build embedded system softwares for microchips and all of that, or self-driving cars. I can decide to use Python to do web scraping or data analytics and all of that. I can decide to even use Python to even build games. But is Python actually built for that? Python is built for numerical analysis, and is built to actually process things better, not faster, but for the person writing the code, it makes it easier for you to write. Not that it makes it better, right? But then it's easier for you to write with. Now, if you are talking about speed for writing a program, you most likely want to be picking more low-level languages like C++, right? For writing programs that are fast, even if it's machine learning. You will tend to discover that libraries for data analysis with Python, like Pandas or Matplotlib or scikit-learn, are not even built with Python. They are built with C++, compiled to Python for Python developers to use, right? There is this big framework called Qt for building apps that run anywhere, both Android, cars, or TVs, or even operating systems, right? And that's Qt, built C++. And then there is the Python version of it, PyQt5, and then there's Py2Side, or is it PySide 2, Py2Side, or PySide, which is just like a wrapper for that. Now, that is because it is more difficult to write that with C++, but now Python does it easy, and then compiles back to C++ to handle everything it needs to handle, right? So focus on actually learning programming and not the language. This same concept of object-oriented and all of this is just something that is available in most languages, except C. C++ has it, C doesn't have it, because C is a procedural language and just writes functions, and that is that for C. But then they are just tools. Any tool that works best for you, use it. I have a friend who is a Python developer who needed to learn about data structures and algorithms, right? I gave him a JavaScript course on data structures and algorithm to watch, because the instructor teaches data structures and algorithm better than other instructors that I know. Among the instructors that I know, he taught it better, right? And he is a JavaScript developer and used JavaScript to teach it. He is watching JavaScript tutorial and seeing JavaScript code. He's not writing JavaScript code, but then translating the version in Python, right? And then there are a community of people who are watching that tutorial. in Ruby, C++, and likes, and then they are rewriting the same code from JavaScript to other languages to show the difference between the languages and how it works, and it works fine. So he's teaching programming concepts, but then using the language to interpret. Meaning you can pick any language and still interpret what he's explaining. So please don't think that Python is the best or because it's easy or whatever. It is built for a purpose and it works best with that purpose. And if the tool you're looking for or what you're trying to build requires a different language, pick that language for it. They are just tools. As long as you understand programming, all you just need to learn in that new language is just the syntax. How to write the language, how do they create variables, how do they write their for loops, how do they write their functions, how do they write their classes, and every other thing you know here, you just bring it back here. What are the data types? So please focus on learning programming rather than programming language. That's my piece.
Wow.
Thank you.
Wow, that's so much. Thank you so much. That's a whole sermon on its own. Thank you. We really do appreciate you. Thank you so much.
Yeah, thank you for coming to my TED Talk.
It was an amazing time. It was, yeah. So, guys, like I said earlier, let's try to keep up with the activities that go on in the community. I'd also like to encourage us, please, if there's anything you're struggling with, just reach out to someone. There's definitely someone on the group who can help out. If you don't want to come on the group publicly, you can even reach out to individuals and see if there's anybody who can help out or probably point you to a resource that can help you improve that area that you're struggling with. We have a community, and the whole aim of this community is to support each other and ensure that we grow together. So please, let's not struggle in silence. Let's come out and get help. Okay? All right. So thank you so much for coming out for today's session. And I'm sure you're happy, just as I am. I'm sure you have gained a lot. So, okay, someone was putting up his hands. Yes. Yes, please. Ibrahim?
Yeah, yes. I said, when will be the next session?
Okay, we're not sure when the next session would be, but once you join the platform, that's the reason why it's important to be on the group. So once you're on the group, you get, whenever we're having a session, there's always an announcement, and the link is always shared.
Get it. All right, thanks.
All right, thank you so much. All right, I think it's time for us to unmute and say good night to each other. And also thank Mr. Moses for the beautiful session.
Thank you, Mr. Moses, and good night, everyone.
Yeah, thank you, Mr. Moses. Good night, everybody.
Night, everyone.
Good night, everybody.
Good night, everyone.
Good night.
Good night.
Thank you so much.